So it's important to note in that last problem that the quadrant is known because the coordinates are given. So we have to consider two angles, but we only give one angle as a solution. So here we've been given the angle, so we know the position. So we only have to consider one quadrant here. So 240 degrees is about here, and that's related to our 30-60 triangles. We need to make sure we know our exact value triangles. Okay, so what are the exact coordinates on the point in the circle with radius 6? So we know that we have to relate this to our special angles. So our special triangle, the long side is √3, the short side is 1, and the hypotenuse is 2. So if this is going to be a radius 6 circle, what I can say is that between these two triangles, there's a scale factor of 3. We don't always have to use the trig ratios, the ratios between the sides. We could also use a scale factor here. So it's a times 3 scale factor. So I know that this length is 3, but I remember that once I go into standard position, I have to consider position. So I know I have to make sure that that's -3. And here we know this is going to be 3√3. The exact value is going to be 3√3, but we know we have to go down 3√3. Okay, so the coordinate of that point is -3, -3√3. Okay, so that's going to locate that. The exact point, so that's important. Exact means we do not use the decimal values. We have to use exact values. Here, this is not an exact value problem because we are now given a ratio, and we're going to need to a decimal ratio, in fact. So it kind of implies that we don't have to use exact values. So we're going to first of all draw this in. So we're given tan, the slope is 3.4. Okay, so I'm going to draw maybe something like that. So it's going to locate this position and this position. Now, since the quadrant is not given, we have to always consider two positions, but in this case, we're going to give two solutions. Okay, because there's two possible answers, because we don't know the quadrant that this occupies. So this is I'm going to call that one theta 1. Okay, and this is going to be 3.41, and since we are dealing with decimals, I'm going to go ahead and find the decimal value of that hypotenuse. So I'm going to go 3.4 squared plus 1 squared, and then I'm going to square root that number. I get about 3.54. Now, if you keep this in exact values, it's perfectly fine, but it doesn't imply, since we're dealing with decimals here, it kind of implies that we don't need to keep in exact values. So first of all, we've got that length. We need to also consider the other triangle here. Okay, so that's going to be -1, -3.4. That's going to be 3.54 along there. And that theta we'll call theta 2. Okay, so I want to write the trig ratios. So I have tan, so I need to write sine theta 1 is going to be 3.4 divided by 3.54. It's approximately 0.960. The cosine, we can use Pythagoras, or we can just use 1 divided by the radius. I get 0.282. Okay, and then solving for theta 1, if I do the inverse cosine of that, I get 73.59 degrees. Okay, so and that's the right quadrant. Those match, so I'm going to keep it like that. I also have to do my theta 2. Now, I don't really need to do any calculations here because of the symmetry of this slope. And I know that if my sign is positive in this quadrant, it's the same sign but negative in quadrant 3. if my cosine is positive 2.282, it's going to be the same but in the opposite direction, so negative 0.282. And if we're dealing with the unit circle, we know that that position in the unit circle is going to be the cosine sine coordinate as the x and y coordinates. And we know that the cosine sine would just be the opposite sign to locate this other coordinate down here, that red dot. Okay, so we can use our unit circle and the fact that cosine sine locate x and y coordinates on the unit circle to help us with the finding that coordinate.